Why? That's interesting. No. I need another point. It's actually a nameless point, which I don't want a label there, but in the code, let's call it P3. And I'm going to put P3 here. No, let's just put it on the y0. Point style, how is that defined? Color index and filled shape on top of point style params default. No, not on top of. Oh, here's the list. Filled shapes. Yeah, I must be able to drag it, so I have to be able to see where it is. there's an ellipse. There's no circle. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Field shape. Oh, yeah, field shape, and then 10, I think. I'm just going to delete this stuff. I won't need it anymore. It's not correct. Stupid order. So you clamp 3 between 1 and 2. And 2's are not really clamped, it just has to be larger than B3 now. Yeah. So this one is clamped between 1 and 2. And this one's clamped between, oops, the wrong ones. That's clamped by the correct one. Also the correct one. So P1 should be clamped by 3, not 1, not 2. I mean 3 instead of 2. No, that's good. Because I know C++ and I don't know Python very well. And C++ is much faster anyway, of course. Okay, now this one can only be dragged horizontally. This one is clamped correctly. Need a vertical line through this one. What will this take? Allow recursion. Need to change S. This must be P3. Okay, so I made a few changes relative to what I finished the string with yesterday. I can now define the fourth degree polynomial simply by having the minimum here going through 2 points that I can drag. I can't drag the maximum as well. That would require a fifth degree polynomial. But this is way easier. Like say you want P2 to be drastically further on this side. And I do want to have this maximum over here. Well, you just have to move this one higher. And then eventually the maximum is in P1, more or less. So apparently, if you want to have this minimum far to the right, then it's also going to be way lower than the other one. And then the cubic is fit through P1 and minimizes the quadratic error between P1 and this vertical line. So we shift it to this side. You get something like this. Shift it to that side. Tries to keep up. Minimizing the quadratic error between these. Maybe I should not have clamped this one actually. Against P2, although yeah. It's just not very realistic if I can get past that point. Yeah, anyway, so the scale is like more or less that distance. You see that the cubic that has the smallest quadratic error between P1 and this line starts to fall pretty fast here. But yeah, what I really want to know, this is all nice that this is the best fitting cubic. What I really want to know is what to do with the cubic that I find after jumping to P2. So now we need a draggable point on the vertical line here. And then we'll also fit the cubic through P1 and that point. I guess. I really wish I had a save button for this. To store all the coordinates. Only printing this. Yeah, let's copy it. P3 was minus 6 or something. I just put it by default at P1x plus difference 0x. Recursion. I don't know. I'm not that good at it. I mean, it's not that special. It's just calculus, making derivatives, doing derivatives of polynomials. I mean, that's easy. A little bit of knowledge. Now, it seems to have worked, as in I get the same picture. Okay, so I want to have something here, new point. Yeah, I guess I'm gonna call that P4 then. Put it here, P4. I think also has an initial value. P4, it is definitely at the x value of P2. And then let's put it at I don't know, 0. I don't know. We don't have a subscript 4 ready. I need it for the I don't have a level. Yeah, I don't know, I want it. To plot P4 is wait, that is filled. Let's take triangle not filled, which is here. Oops. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this thing must keep the x-coordinate of plot 2. So we copy the x-coordinate of plot P2. No clamping. Just have returned that directly. No. This is vertically draggable over this line. And I want to add a cubic that is fits through P1 and this point. P1 and P4. Cubic. Guess I'll use initialize then. Oh, this is nonsense. Plot doesn't even have a derivative. So let's call this thing D1, the derivative, and here we have a derivative of D4. And then plot it. The derivative in point P1 is, you can define that up here. That is the derivative in x1. Oh, wait a minute, that's too far. dp is already the derivative. I didn't define that yet there. Yeah, well, P1. And D4. That's actually the same thing, isn't it? No, totally not. You need a new point. Damn it, and I deleted all that code already. Shit. Yeah, the list is getting too long. I don't know. Yeah, make it draggable. And do we need that for? Oh, it's just all the same thing. Direction, we'll call that 4, I guess. What do you mean, what exactly is this all for? Did you read the description below the video? I mean, I can answer that question in 50 different ways. No, I'm missing something. It's not even drawn now. Yeah, obviously. Need to continue with adding the code for Q. Draw an arrow. And I get the direction, I guess. I think, yeah, we wrapped. Okay, so add it here. 4. Oh, that's no, I did it again. Well, never mind. You still have it here. Oops. What? I keep pressing the wrong button. Alt tab, not Control tab. And I have to convert this direction now into a slope or a derivative. That's an arctangent of the angle, isn't it? Something like that? No, yeah, I don't know. I think the other code using an arctangle is something arctangents. No idea how you pronounce that. But it kind of, yeah, nonsensical. Much better. Let's just do this. So, I was doing it in the right way. Thought maybe I took a detour through calculating the tangents to get an angle, and then from the angle back to this ratio, but you can just obviously just calculate it directly. So if I have the d4 here, then I might as well calculate d4 from that, which is my derivative in 0.4. So now I have d4, which means that it will compile. Compile. Yeah, compiles. No circle. I forgot to draw the circle. And the circle radius can be like way bigger. I'm gonna change the 0.2 into 1. There must be a 0.2 somewhere. Just change that into 1. And we forgot to draw the circle. Create a point Q0 on the circle. Circle. Draw a circle. This is the draw a circle thing. Around B something. Yeah, well, I like to spend as little time as possible doing CMake stuff. But I did put 2 or 3 weeks of doing nothing else. I mean, you have to really learn it, understand how it works and stuff, and then you can use it. Many people want things to come automatically for free, so they start using CMake without putting time into actually mastering it, and then nothing works. I mean, yeah. I didn't buy a book about it, but theoretically, if you are a professional using CMake, then theoretically you should buy a book about CMake and then study that in your free time until you are a master in how to use CMake. Now that's what I call a circle, and I can't drag it, and we even crash. Yeah. Okay, this is annoying. Drag. Make you draggable. Why would that not work? So this defines a direction from point from to point to. So this is from the center of the circle to the new position of where I drag Q to, which is on the circle. So unless you flip your wrist and drag it exactly to the center of the circle, nothing can go wrong, I would say. I have absolutely no idea why it crashed, or why it wasn't draggable for that matter. So run it again. Let's see if it crashes because I was dragging anything. Let's drag here something. See, that works. Still works. This still works. This still works. Oh, it's not moving along. So I have to update that. Just drag, that crashes. That didn't crash before. That was P4. So dragging P4 crashes, but why? But I'm not found. Let's make Q4 not draggable. Let's add a label at, already have a label at P2. So let's not update Q4. I think this code worked. Yep. So this is Q here, and I can now not drag it, and it doesn't move along, as you can see. And there's something else wrong. I mean, I can't move this left and right, only over the line. But if I drag this, whoops, it jumps back then. Okay, we have to move. You have to move this along if you move P2. It's an unrelated problem though, but might as well fix it. So if P2 is being dragged, then we must move P4. And the usual way to do that is we must move Q4 as well, but okay. I must move 0.4, yeah, so P4. Move that to, plot, comma, to, yeah, what it was indeed. Let me think. X coordinates changed. We'll keep the Y coordinates. The X coordinate must be the same as the new one here. Let's see if this compiles. Move takes a plot and a point, so that should compile. Let's make small incremental changes and then see what happens. Where it doesn't compile, for example. Variable plot P4 cannot be implicitly captured in a lambda with no capture default specified. Oh, so lame. I just forgot to capture it. Must be by reference because we're changing it. So if now I move this thing has moved along. Wow. It's a bit lagging and not, it's like, it's like literally, no, yeah, it's not updated. Wow. Sometimes, well, it has its own mind about the pixel where it goes to, I guess. Got the feeling that there is a round-off problem here. Say one of them goes to the ceiling and the other one just rounds it, or the floor probably. Strange though. Everything should be doubles. Yeah, we should move this one along as well. So maybe use translation. Nah. It's inaccurate. Do I have a D4 here? Defined inside loop, I mean. Inside the while loop. So we are not even inside the while loop now. No. Plus can't grab it later. So you have to redefine this then. Inside the lambda. No, I move P4 here, so I have to do that first. So get a direction vector from the center of the circle to the 2Q. And then use that again to move Q4. And we crash. I should just run it in the debugger probably to see what is going on. It's just that call. No, still don't know. Oh. I lost my mouse. Well, I can still move the mouse, but we lost. I can't use it anymore. Alt-Tab. Is that working? Yep. Use my mouse now? No. Do we have a terminal somewhere? I can just press Ctrl-C. I think. Hardly. Quit. Yes. Let's debug this again, but now move it away. Again, no mouse. This is 241, so very uninitialized. Draggable restrictions. No, this pointer. Plot. Plot is uninitialized in move draggable. We got plot from clickable plots, clickable index. Super annoying. It looks very not initialized. At the very least, clickable index is a nonsense. Maybe it's -1. No, wait a minute. I want to do the plots. Length 5. Everything is the same thing. It's just the plot pointer, I guess, is 5 times the plot pointer. But yeah, the clickable index is no -1. Index. Point index. I guess that means that this point is not draggable. Index is -1, yeah. Draw objects. It seems to be Q. Looking at the coordinates. Only Q is at coordinate 15 and Y, yeah. This must be Q4. So Q4 is not registered within an index. So it's not registered, period. Oh, it's being moved here. Yeah, of course it's being moved here because I moved P2. So this is that lambda. So plot P4. No. Plot Q4. Yeah. Let's compare that with this one. That one does have an index. Why the hell is this commented out? Okay, so so we crashed because I'm moving Q4 while it was never registered as draggable. Then you can't move it apparently. Yeah, let's instead just not do this, whatever that is doing. Because we did crash somehow. Just return new position. At least then it is draggable. So we should be able to move it. I should add an assert for this. Where exactly did this go wrong? I think here, using clickable index. I think I'll go here. It is a vector index from utils, so I can just test if it is defined. Undefined. Hallo Tony. Still crash. And still can't use the mouse. So annoying. It's still not a good disk pointer. What? This is at another. Still -1. I don't have an assert here. Apply restrictions. So again, move dragable. Index of points. Did I forget to recompile it or something? This. I asserted on too late. Already using it here. Must be put at the top. So it seems to be still not registered. Well, I did uncomment that part. Did I forget to recompile it? No, I did not. It's probably better to throw an exception though. Otherwise my mouse becomes unusable. If I asserted that place. Q4. Okay, even better. Yeah, I don't know. The only thing I can think of now is that it is already being called before we get here. But it isn't. No, we already... It draws everything. We should have gotten here. It should have been... Oh, never mind. That's I'm registered P4 for the second time. How much time did we just lose? Half an hour or something? Since the first time it crashed? Unbelievable. I guess I should add debug code to the text that you register the same thing twice. Got it. Why not? So if we call register draggable on something that already has index set, we also should assert. Guess you need to plot register draggable. This is plot. And that is oh, it's just plot. That's not one. Window. This is the one. Yeah, but then we call plot. That's a better place, I guess, to check it. So we must check it here. And then draggable set index being called. Which is this one. Undeclared. Good. So if I move this, Q is being moved along. This is, I don't know, dragging this thing. What's happening here? So not what I want. Yeah, it is moved along, but we're kind of losing the direction there. And this is just working, I guess. To put this thing under 45 degrees. Just to move this, that works. Nothing goes wrong. But if I move this point, sometimes the direction is lost, like here. Especially if I move to the left or the right. It seems to change the direction. Not good. But this is 0.4. So dragging 0.4 messes up the direction of the D4 direction. Ugh. I must use a result here, of course. Or do the same thing as here, just calculate the direction at the start. It should work as well. No! Still not changing it. It's like it's grabbing Q instead of this one. Or both, maybe. See, I grab it like this. Yeah. I don't know. And we have another one. Great. This should also be this. Really? No. Let's use the D4 way. Begin with getting D4, move to center, and then move Q4 simply to the center plus No, whatever it should be with respect to D4. Jesus. It kind of worked? No, well, not really. What the... Wow. It's not happy. Totally not happy. It's confusing shit, this. Oh, let me crash. Midwest Metro, yeah, well, my own. It's called Cairo window. If you're referring to what I'm using to draw this stuff. What am I doing wrong? So the idea is you, at the moment you register something as being draggable, its geometry, which is a tiny square, is stored somewhere, so that if you click with the mouse and while you are at or have the mouse in that geometry, in that little square, it starts to call functions with the movement of the mouse, so you can move it around. And one of the things that it then does is call this lambda with the new position of, I guess, well, yeah, it must be a point, I guess. So you click the only things that are draggable points. So you move the mouse and then you have a new position where that point wants to go to. And like in this case, we have if we drag the center of the circle, then we just want to have the point that is on the circle to move along. This always worked perfectly fine using certain code. But now I have restricted the movement of the center to only vertical movements. I have no idea why this would not work. I mean, okay, I restrict it, but then let me have another stab at this. I'm going to use clamp check. Yeah, dragging Q. Well, that's Q0 and Q1. Okay, so here, dragging the center, P1. Then Q1 is just moved. The translation. This. Okay, just copy this and use that for the center, so for P4. But if I do that, then I haven't not restricted it to stay on the vertical line. But okay, it should not be a problem. So now I just put it like there, and if now I move this, the point on the circle just moves smoothly along. Just translate it the same way, and the angle stays the same. This always worked. However, I can move it away from the vertical line. That's not good. So try to fix that. So instead of returning new position, I want now to return a result. I'm going to call that new P4 now. And I'm going to return new P4. Let's see, direction. I don't want to use direction. Okay, and the new P4 is then restricted to the x coordinate of P2, but it does copy the y. So basically this is now a replacement for a new position. But having a new position is use only the y coordinate of the new position. And then this is returned. But then this code must be changed as well, where we use new P instead of plot P. And if this does not work, then I'm feeling stupid. It doesn't even compile, can you imagine? New Q4, that's not what I wanted. Sorry. No, there was a definitely, it was simply Q4 plus translation. Should not have changed that plot. Yeah, it just doesn't work. Clueless, that's what I am, completely clueless. Why the hell can't I not get this to work? I guess I'm just stupid. If this now works, then I'm stupid, because I had it wrong. Yep, I was just stupid. Jesus. Okay, well, at least it works now. So then, back to the drawing board. The idea is that we had enough information to plot this fourth degree polynomial. And assuming that the fourth degree polynomial is an exact fit of the actual underlying function, we jump to the minimum because we want to go to a minimum. But instead of finding something exactly, I mean, if the actual function was fourth degree thing, then we would have found a point with a derivative of 0, exactly in the point where we expected it to be, which then would have resulted in the green cubic being fitted, where the cubic does not fall on top of the real function, which is then apparently the fourth degree function, because this is a fourth degree polynomial and this is only a third degree polynomial, so it can't fit. But the minimum is good. So that's one thing that went wrong. This would be the perfect cubic, because it's exactly where it should be. The derivative is okay, it's 100%. We just found the minimum, yay. And still, it has an enormous deviation from the 4 degree thing. So this error is very big. But that's a problem of the fact that it is a cubic, not a problem of finding the correct point. So apparently I cannot use or look at this arrow here. I cannot look at the angle that this vector makes with that vector, for example, which is the other thing that I was doing, which didn't work. But if what we get back is something unrelated, like all the way up here, let's say with so we find this. Now this cubic follows the fourth degree prediction very accurately within the scale up till this point. But clearly it has nothing to do with the fourth degree prediction of its minimum, because this is like, infinitely somewhere else. And also the derivative is completely wrong. So if this cubic is any indication for what the real function does, well, we know that the real function goes through this point and has that derivative here. And since we also know that this is accurate, so we know that the slope here, the derivative, is negative, and the derivative here is positive, which means that there must be a minimum between, let's say, it's accurate within this range, so there must be a minimum between here and there. Must be. And the cubic predicts that it will be here. But is this now a usable cubic? Because the further we go to that side, the more accurate the fourth degree polynomial will be. And that dives down. So if you go like here, and you say, yeah, well, maybe this cubic is not a good predictor, because it seems that we're going down fast. So it's more likely than that, maybe there's a minimum here or something. I had it so much more clear somehow in the test case where it went wrong. Maybe, yeah, it was even, it even went up there, so maybe I should do something like this. And now we don't have a minimum at all. That's also not what happened. It was like this. Put that one a little bit. It was a little bit like this, I think. Yeah, something like this. So you can see that we jump to this point, and then we expect to get a zero derivative and a point at minus 15. But instead we get something at plus 12 with a positive derivative. So apparently the real function is doing something completely different than diving down and then going like this. But okay, going like this is not what it does, but it is diving down. I mean, this is an accurate prediction. It's not here, it's going to be here, right? We assume that within this scale it's correct. So the real function is going down here, not doing that. So that indicates, in my opinion, that there must be something going on that requires more than one cubic. I mean, if you just fit one cubic, you get this thing, and that's just too far off here. We need something that goes down, and yeah, and then in the end ends up here. Well, if you want to have the perfect fit, the perfect cubic that follows this curve in this range is the red one, so that doesn't come here at all. I don't really know what to do. The only thing, I mean, at some point you say, well, clearly it is going down, so there must be a minimum here. And for example, I mean, the actual function was doing something like minimum, maximum, minimum, maximum, and then, yeah, you by that time you just get a random derivative, which is depending on exactly if you're a little bit left or right of that the maximum that we are counting here. So we jumped over many minima. But when exactly does it get likely that you did jump over a minimum? Another minimum than this minimum? This is pure statistics. I have to come up with a function that goes through this point and has this derivative, and goes through this point and has this derivative, but begins going down here. Well, it could go like this, have a minimum here, and then go up again, and then, well, you know, having one minimum, and then, I don't know, attaching to that point again somehow. But yeah, if you try to do that, well, I don't know, man. Maybe, okay, maybe going down pretty far and then have a minimum and then have a maximum in this area. At least then I can fit the, yeah, then I can fit the derivative here. So if this point is close to a maximum, then maybe we can have jumped over just a single minimum. So in that case, it would not be that bad, I think, to just halve the jump distance and try this point. But when do we do that? In this case, I would do that. But when exactly? When mathematically Is it more logical to ignore this minimum and just half the jump distance? Or even go straight here? Try that too. And then I mean, of course, for example, as function of this. I mean, if I move this down, now it matches the fourth degree polynomial much better. And then if I move this a little bit up, it's even better. It's pretty close here. I don't think that in this case I can say, well, let's just ignore this whole cubic and jump here. I think it makes sense to jump here though. But yeah, I'm not sure. Totally not sure, man. Statistics. I just have to, I think I should just generate a lot of functions and test it out and then see at which type of functions we actually jump over a minimum and when do we do not. And then you could throw all that data in a neural network to find out when, and then simplify it again, and then hope to see what the answer is. Something like that. It's the only thing I can come up with. So the problem is that if you jump over a minimum, and well, often the new minimum of the cubic is even past the actual minimum. So let's say there's a minimum here and then a maximum, and then we come back here. And if you jump here, you find this minimum, of course, not that one. So what is going to happen is that they can ignore the fourth degree. If we just move that thing to, let's say, here. So we jump here, and then eventually we find a minimum. So the derivative is going to be horizontal. And this then matches the real function, this sample. And then we have a cubic that is fitting P1 and fitting this minimum. But the actual function then thus went down here, had a minimum here and a maximum here, and a minimum here. And we just jumped over this minimum here. And in that case, I would say, well, this is a strong indicator. The fact that we do not follow the red line here in order to get there. If this is the minimum, the next minimum after this maximum, then why is my fourth degree polynomial going down so fast? Yeah, that's not true, of course. I moved this point now because I wanted to have this minimum here. Maybe I should make this free moving. I should make it free moving. Yeah. So P4 should not be restricted in the x direction. So we can explore other cubics. I'm going to have to stop and eat. Okay, so let's say we find this, and then we jump here, and then the actual function is something like go down, down, up, down, down, up, down, and this is the one that we find. So I want to move here, and then make this horizontal. And it's not even deviating within the scale very much. It could still happen. Maybe I should just not jump this far. Period. It's like, I mean, I'm trying to speed up things, so it makes sense to try jumping here. But it seems to be hard to recover from an error afterwards. So making smaller steps, maybe, I don't know. I'm having the feeling that this cubic here is going through minus infinity. Can't see that though. Yeah, it is. So you have a minimum here and a maximum there. Doesn't really change, I think. The minimum moves slowly out, slowly to the left outside. Here now it's on the edge, and now it's outside. But clearly the minimum is on this side, not on this side. So this cubic has nothing to do with this cubic, which has a maximum first. I think it should fit a cubic that has a minimum on this side. The red thing is not a good representation actually for this thing. It has a minimized quadratic error, but I want to have something that goes up again here, and then minimize that quadratic error for that. Good, I'm going to stop and eat.